Let us continue foundation chemistry, Iupac nomenclature. In the previous class, we have seen alkanes nomenclature we have seen. Now we will continue. In the alkanes, some more molecules we will take. Now we will take the molecule like this. We will take one molecule in this way. We have taken a molecule like this. For this molecule, how to say Iupac name we will see. So Iupac name in the sense, first we have to select a parent chain we have to select. What is parent chain? Longest continuous carbon chain is called parent chain. Okay, now we will select longest continuous parent chain. That is what means this. This is longest continuous parent chain. Longest continuous carbon chain, therefore it is called parent chain. This parent chain contains how many carbon atoms you see? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms are there. Therefore, a root word is oct. Then carbon-carbon single bond is there. Therefore, primary suffix "-ane". Then we have to say prefix. Which and all coming under prefix, that we will see. Which and all coming under prefix means this methyl group comes under prefix. Then this methyl group comes under prefix. 2 methyl groups are there. Therefore, we will write dimethyl. We'll write dimethyl. Now we have to say the position of these 2 methyl groups. We have to say, for which we have to give numbering. We have to give numbering. You start from either left extreme of parent chain, otherwise right extreme of parent chain. Okay, now we will write suppose we are starting from here, number 1, here 2, here 3, 4th carbon, 5th parent chain carbon, 6th carbon in parent chain, 7th carbon in parent chain, 8th carbon in parent chain. Now this methyl group is attached to 3rd carbon of parent chain, so the position of this methyl group is 3rd. Okay, then this methyl group is attached at 6th carbon of parent chain, therefore position of this methyl group is 6. Therefore we can say 3,6 dimethyl octane. This compound name is what in the sense? 3,6 dimethyl octane we can say. Now we will take another molecule. We are taking the molecule like this. We have taken the molecule like this. Now, for this molecule, how to say the name? We will say, first we have to select parent chain. Parent chain means what? Longest continuous carbon chain. Okay, let us select longest continuous carbon chain. Longest continuous carbon chain means that should contain highest number of carbon atoms. So in this chain, highest number of carbon atoms are there, or some other chain is having highest number of carbon atoms. Check and say. Shall we say this is having highest number of carbon atoms? Okay. How many carbon atoms are there? Count 2, 4, 6, 8. Therefore, oct. We can say oct. Oct is the root word. 8 carbons are there in the parent chain. Therefore, we said oct. We said. Then we will say primary suffix. We will say. What is the primary suffix? Means carbon-carbon single bond is there. Therefore, ane. Carbon-carbon single bond. Therefore, ane we can say. Next, we will see branch. This is branch. This ethyl is present at branch. This CH2, CH3, this is called ethyl. This ethyl group comes under prefix. How many ethyl groups are there in the sense? 2 ethyl groups are there. Therefore, we can say diethyl. Now, this ethyl group position we have to say. This ethyl group position we have to say. For that, we have to give numbering. How to give numbering? From which side shall we start? Okay, suppose we are starting like this. We are giving numbering like this. If we give numbering like this, then the position of this ethyl group is 4. The position of this ethyl group is 5. Therefore, 4, 5. If we give from this side, then 1, 2, 3, 4. Then also 4, 5 only is coming. So, any side we can give numbering. Okay. Next, we'll take next family called alkenes we can take. For this general formula is CnH2n. Now we will substitute n is equal to 2. Minimum 2 we have to substitute. N cannot be 1 because ene in the sense, this ene in the sense carbon-carbon double bond. CC double bond is called ene. CC double bond is called ene in the sense alkene should contain minimum 2 carbons. Okay. Therefore, it is containing minimum 2 carbons. We said. Now we will say we will substitute n is equal to 2. We can substitute, or n is equal to more than 2. Also we can substitute. Suppose we are substituting n is equal to 3. Okay. Then what is the formula in the sense C3H6 we can say. Now 3 carbon atoms are there. 3 carbon atoms we will write. Then this formula coming under this category. This category in the sense you have to give one CC double bond. You have to give. Okay. You have to give one CC double bond. So one CC double bond let us give. Then between remaining carbons you give single bond. Between remaining carbons you have to give single bond. Okay. Then we will give hydrogens. For this carbon let us give 3 hydrogens. Then only valency will be satisfied. This carbon is having 3 bonds. So give additionally 1 bond. This carbon is having 2 bonds. Therefore give 2 hydrogens you give. Okay. So this we will write in a condensed formula. CH3 single bond CH double bond CH2 we have written. For this what is the parent chain we will select. Parent chain is this is parent chain. This parent chain contains 3 carbons. Therefore root word is prop. Here carbon-carbon double bond is there. Therefore primary suffix give ene. Okay. When double bond is there, don't consider carbon-carbon single bond. When double bond is there, don't consider carbon-carbon single bond. Why? Because CC double bond is having higher priority when compared to CC single bond. Therefore, based on CC double bond only, you have to give primary suffix. Okay. So CC double bond, for that, what is the primary suffix means ene. Okay. Sorry. So this compound name is, we can say propene, we can say. Next we will substitute n is equal to 4. N is equal to 4 in the sense we can write formula is C4H10 we can write. C4H10 is not possible. C4H8 is possible. Okay. So we are taking C4H8. So n is equal to 4 we have substituted. So we got C4H8. What are the possible structures for this? That we will see. So for this, what are the possible structures we have to write? One is one structure we can write like this. One possibility is like this. Next possibility will take. Next possibility is like this. Next possibility will take. Next possibility is like this. Okay. So one double bond you have to give. In the remaining place you have to give single bond. Okay. CC double bond, one place should be there. One double bond you have to give, remaining place single bond you have to give. So 3 possible structures we have written for C4H8. Then we will give hydrogens. For this carbon we can give 3 hydrogens we can give. For this carbon 2 hydrogens. For third carbon 1 hydrogen. For last carbon 2 hydrogens. Then here first carbon 3 hydrogen, second carbon 1 hydrogen shall be give, third carbon 1 hydrogen, fourth carbon 3 hydrogens. Then for this molecule, first carbon 3 hydrogens, second carbon no hydrogens, this carbon down carbon 3 hydrogens, last carbon 2 hydrogens. Okay, we have given. Now we will say Iupac name. We will say first we will select parent chain. Here it is a parent chain. This parent chain contains 4 carbon atoms. 4 carbon atoms means root word is but. Double bond is present. Therefore primary suffix ene. Okay. Here we will select parent chain. Here parent chain contains 4 carbon atoms. Therefore root word is but. CC double bond is there. Therefore primary suffix ene. Okay. Now here double bond present at terminal. Here double bond present at a center. Therefore position of double bond is different. Position of double bond is different. Therefore these two are called position isomers. Those two are called position isomers, we can say. Those two we can call it as position isomers. Position isomers means what? Position is different. In these two cases, here position of double bond is terminal. Here position of double bond is center. Therefore position of double bond is different. Therefore we can call them as position isomers, we can call. So Now let us say position of double bond. For that, let us give numbering. Okay. Now we can say here number 1 carbon, number 2 carbon, number 3 carbon, number 4 carbon. Now double bond present between first carbon and second carbon. In that list is number 1. That 1 we will write here. Now we will say double bond position is 1. Then here also we will give numbering. Number 1, 2, 3, 4. Now double bond present between 2 and 3. Therefore position of double bond we will say 2. So that we'll say it is but 2 in. This we will say as but 1 in, we will say. Okay. Next we will take this compound. For this compound, we will select parent chain. We will select the parent chain is what in the sense. This is the parent chain. This is the parent chain. So we have selected a parent chain for this compound. Then this carbon is not coming under parent chain. Therefore, this we have to call it as branch. So in this compound, parent chain is there, branch is present. Parent chain contains 3 carbon atoms. Therefore, root word is what in the sense prop. Here CC double bond is there. Therefore, we can say in. Branch is there. Branch name we have to say as a prefix. This branch name we will say as a methyl. Branch name we are saying as methyl. Now we will give numbering. Numbering how to give in the sense start from right extreme. Start from right extreme. Here number 1. Here number 2. Here number 3. So branch position is 2. Therefore we will say 2 methyl. This double bond position is 1 we have to say. Therefore 2 methyl prop 1 in. So this compound name is what in the sense 2 methyl prop 1 in, we can say. Okay. So next compound we will take. Now we will take a C5H10. For this, how many isomers possible do you say? First, for this, how many isomers possible we will say. Okay. It is number 1. It is number 2, number 3. Now we will take number 1 and number 3. Number 1 and number 3 are called which isomers? In number 1, parent chain contains 4 carbons. In number 3, parent chain contains 3 carbons. Therefore, parent chain contains a different number of carbons in 1 and 3. Therefore, parent chain length is different. Therefore, 1 and 3 are called chain isomers. 1 and 3 are called chain isomers, we can say. Then 2 and 3 we will take. 2 and 3. In 2, parent chain contains 4 carbons. In 3, parent chain contains 3 carbons. So in 2 and 3, parent chain contains a different number of carbons. So in 2 and 3, chain length is different. Therefore, 2 and 3 are called chain isomers. Next, we will see position isomers. Position isomers means what? Position will be different. In 1 and 2, position of double bond is different. Therefore, 1 and 2 are called position isomers, we can say. Therefore, these 3 are 1, 2, 3 are called structural isomers because structure is different. Okay, so that for C4H8, how many isomers possible in the sense we have written 3 isomers, we have written still more also possible. That structure we do not know. Therefore, we will discuss later regarding the other isomers of C4H8. Okay, sir. Then we will take C5H10. In C5H10, how many isomers possible? That we will write. First one, how to write in the sense write 5 carbon atoms straight. Then give double bond at extreme. Then remaining places give single bond. Okay, sir. Next, give double bond at second carbon. Give double bond at second carbon. Okay. Then don't give at third carbon because if you give numbering from left side, it will come as a double second position. Therefore, don't give it. Sir. Okay. Next, write this carbon under this. Okay. So we are writing 4 carbons. So this carbon we are writing under this. Then write this carbon under this one. So we will get like this. Like this we got. Next possibility. That's all. There is no more possibility. Okay. We cannot write this carbon here. Yeah, this carbon we cannot write here. That can we write these 2 carbons here? Not possible. Therefore, only these 4 are possible. Now we will give hydrogen atoms. We will give hydrogen atoms. For this carbon 3 hydrogens. For this 2 hydrogens. For this carbon 2 hydrogens. For this 1. For this 2. Now here 3 hydrogens. here 2 hydrogens, here 1, here 1, here 3, here 2, here 1, here 1, here 3, here 3. How we are giving hydrogens means carbon is having how many bonds you see. In order to get 4, how many are required? That many hydrogens you give it. Okay, sir. This carbon is having 1 bond, so it is in need of still more 3. Therefore, give 3 hydrogens in order to get valency 4. Here giving 2. Here this carbon is having 4 bonds, so it is having satisfied valency. Therefore, don't give hydrogens. Here 3 you give, here 2 you give. Okay, so we have given hydrogens we have given. Now we have to select the parent chain in order to say the name. Now for first compound, the parent chain is this one. This parent chain contains 5 carbon atoms, therefore root word is pent. This parent chain contains 5 carbon atoms, therefore root word is pent. This parent chain contains 4 carbon atoms, therefore root word is here 3 hydrogens only we have tried. No, here mistake is there, 4 hydrogens not possible, 3 hydrogens only. This parent chain contains 4 carbons, therefore bute. This parent chain contains 4 carbon atoms, therefore it is bute. Okay, then everywhere CC double bond is there, therefore primary suffix is in. Everywhere primary suffix is in, we have to say, because CC double bond is present. Then we have to say prefix. For this no prefix, for this no prefix. Here prefix is there, that is what means this methyl. This methyl is the prefix. So we are here prefix is what in the sense methyl. Here prefix is what in the sense this methyl. This methyl is the prefix. Okay, we have written prefix, we have written. Then we have to say position, we have to say. Okay, now we will say the position. Here number 1 we will give here, so double bond present at first carbon, therefore pent 1 in. Here number 1, number 2, double bond present at second carbon, therefore pent 2 in. Here number 1, number 2, number 3, number 4. Now double bond present between 1 and 2, in that least is 1, so take 1 as a position of double bond. This methyl is attached to third carbon of parent chain, therefore 3 methyl. Here numbering, first carbon, second carbon, third carbon, fourth carbon. Now double bond present between first and 2, therefore double bond position we have taken as 1. Methyl position is second. Okay, like this we can say the name. Now in this case, why to give numbering from numbering starting from right? Why can't we give from left? We can give from left also, but double bond position will change. Okay, when double bond and branch is there, which should have least position, means double bond should get least position when compared to branch. When double bond and branch is there, which should get least position, in the sense double bond should get least position. Therefore we have to give numbering starting from right only, not from left. Okay, so start numbering from right, don't start from left. Why? Because if you start from right, then only double bond will get least position. Okay, therefore numbering start from right only for this compound cell. Now we will say which are chain isomers, we will say. Which are position isomers, we will say. Chain isomers means what? Chain length should be different. Okay, sir, it is first compound, it is second compound, it is third compound, it is fourth compound. Now say the chain isomers. Chain isomers means chain length is different. That means number of carbons in the parent chain is different. Now see where number of carbons in the parent chain is different. 1 and 3 shall we say? Yes. So 1 and 3. Then 1 and 4, correct. Then 2 and 3, yes. Then 2 and 4, yes. How do we say in 2 and 4 parent chain length is different? In 2, number of carbons in the parent chain is 5. In the 4, number of carbons in the parent chain is 4. Therefore here parent chain length, here parent chain length is different. Here chain length is more, here chain length is less. Therefore these numbers are called chain isomers. Then position isomers, will say. Position isomers means position is different. If position is different, then we have to say position isomers. Now in this compound, position of methyl is 2. In this compound, position of methyl is 3. Therefore, position of methyl group is different for these two. Therefore, these two are position isomers. Okay, like this we can say. Then we will see position of double bond. We'll see here position of double bond is 1. Here position of double bond is 2. Therefore, in these two cases, position of double bond is different. Therefore, this 1 and 2 are position isomers we can say. Sir, can we write any more isomers for this compound? Any more isomers possible for this compound or not possible? Yes, possible. What? This double bond we can write here. This double bond we can write here. That is one possibility, sir. Okay, so we will write this double bond here now. So carbon, single bond carbon, here methyl group, here double bond we want to write, here carbon, here carbon. Okay, like this possibility is there. Then we will give hydrogens, we will give here 3 hydrogens, here no hydrogen, here 1, here 3. Now we will select parent chain. Parent chain is what in the sense? This is the parent chain. Okay, now we will give the numbering. Numbering we will give. So here numbering 1, here 2, here 3, here 4. Here we have started numbering giving from left. Why? Because then only double bond will get least position as well as branch will get least position. Don't give numbering from right. Don't start from right. Okay. So start from left only. Now we will say the name. First prefix name we will say. Prefix is this methyl. This methyl present at second position. So we can say 2-methyl. Okay. Prefix we said. Then parent chain name we will say. Parent chain contains 4 carbon atoms. Therefore root word is but. Then position of double bond we will say. Position of double bond is 2. Double bond name is what? In. Okay. Now it is number 5. Fifth compound also we said. Now you say what about 1 and 5? 1 and 5 shall we say chain isomers? Yes. Okay. 1 and 5 we said chain isomers. Sir, okay. 1 and 5 is called chain isomers you said. 1 and 5 chain isomers you said. Can we call this is as a position isomers? Can we call this is as position isomers? Number 1 and number 5 are chain isomers we said. Why? Here parent chain contains 5 carbons. Here parent chain contains 4 carbons. Therefore 1 and 5 chain isomers. Shall we say 1 and 5 position isomers? Yes or no? Because now you say position of double bond here is 1. Position of double bond here is 2. So position of double bond here, position of double bond here different. Therefore this first compound and fifth compound are position isomers. Okay, so like this you can say many things you can say as a position isomers pair, chain isomers, like this you can say. Okay, now if you take this compound, this fourth compound and fifth compound are position isomers we can say. Why? Because in this place position of double bond is 1, here position of double bond is 2. Therefore this fourth compound and fifth compound are position isomers we can say. Okay, sir. Sir, for this C5H10, can we write any more compounds? Any more compounds? Is it possible? That means, shall we write this double bond here? This double bond shall we write here? That is nothing but this. That is nothing but this. Therefore, we need not. Okay. Then any more possibilities there are what you see? Okay. So like this, we can write this alkene. We can write. Next, we will go for alkynes. We will go. Next, we will go for alkynes. Alkynes general formula is CnH2n minus 2. Alkynes general formula is CnH2n minus 2. Here, what is the prefix is there means ine is there. This ine means, here ine is there. Ine means what we have to say means C triple bond C. This ine means we have to say C triple bond C we have to say. Okay, sir, ine means 1 C triple bond C should be there. Rest of the between rest of the carbons we have to give single bonds we have to give. Okay, now we will substitute n is equal to 2. N is equal to, if we substitute we will get C2H2 we will get. Okay, n is equal to 2. If we substitute we will get C2H2 we will get. Now 2 carbons are there. The 2 carbons we will write here. Between carbon atoms give triple bond. Between carbon atoms give triple bond, give it. Then 2 hydrogen atoms are there. One nitrogen will write left side, one nitrogen will write right side. Okay. So here 2 carbon atoms are there. 2 carbon atoms means this alk. Alk word is eth. Then triple bond is there. Therefore, we have to say ine. Therefore, we can say this name is ethine. Ethine is the Iupac name for this. Okay. This we can write even like this also. CH triple bond CH. Like this also we can write. Then we will write N is equal to 3. We will substitute. We will substitute N is equal to 3. Here we will write 3. Therefore, we will get C3 H. How much in the sense H4 we will get? C3H4. Here 3 carbon atoms are there. So we will write 3 carbon atoms like this. Then this is coming under this category. Therefore, between carbon atoms give triple bond. How many triple bonds means only one triple bond you have to give. In the rest of the places, you give single bond. In the between rest of the carbons, you give single bond. Okay. Then we will give hydrogens. We will give now hydrogens in the sense for this carbon we will give 3 hydrogens. We will give for this carbon. Don't give hydrogen. For this carbon, give 1 hydrogen. Now, what is the name of this? We'll see. This compound contains 3 carbon atoms. Therefore, prop we will say. Carbon-carbon triple bond is there. Therefore, what is the primary suffix? Shall we say ine? Okay, ine we are saying. Therefore, name of this compound is propine. Name of this compound we can say propine. Next, N is equal to 4. We will substitute here. N is equal to 4. We will substitute. N is equal to 4 in the sense C4H6. Okay. Now 4 carbon atoms are there. 4 carbon atoms. Let us write like this. Then we will give triple bond. Where we have to give triple bond in the sense at terminal you give. In another case, you give triple bond at center. Give triple bond at center. Set. Then between remaining carbons give single bond. So between remaining carbons you are giving single bond. Then let us give hydrogens. Here for this carbon give 3 hydrogens. For this carbon give 2 hydrogens. For this carbon no hydrogens. For this carbon 1 hydrogen. For this carbon give 3 hydrogens. Why? Because it is having 1 bond. For this carbon shall we give hydrogen? No. Why? Because this carbon is having 4 bonds. This carbon is having 4 bonds. Therefore don't give hydrogen. This carbon is having 1 bond. So how many hydrogen shall we give? 3. Okay. So we have given like this name. Now we will say the name of this one. Here parent chain contains 4 carbon atoms. Therefore but. Here triple bond is there. Carbon-carbon triple bond is there. Therefore, primary suffix is what means ine. Here also root word is but because parent chain contains 4 carbon atoms. CC triple bond is there. Therefore, primary suffix is what means ine. So it is butane. It is butane. Now we have to say position of triple bond. We have to say. To say the position of triple bond, let us give numbering. For this carbon number 1. For this carbon number 2. Now triple bond present at first carbon. Therefore, we can say it is but 19. Here position of triple bond is 1. That means triple bond present between 1 and 2. Here we will give the position number 1, number 2, number 3, number 4 will give. Here triple bond present between second and third. Therefore, triple bond position is 2. We will say triple bond present between second carbon and third carbon. Therefore, position of this ine is what in the sense 2 we have to say. Therefore, it is called but 2ine, whereas it is called but 19. Now you say but 19 and but 2ine are coming under which isomers? Shall we say structural isomers? Yes. Why? Because structure is different. Therefore, structural isomers. Shall we say chain isomers? No. Why we cannot say chain isomers? Because here parent chain contains 4 carbons. Here also parent chain contains 4 carbons. Therefore, number of carbons in the parent chain is different for these two. Different? No. Number of carbons in the parent chain is same for these two. Therefore, these two are not chain isomers. Sir, okay. Shall we say these two are position isomers? Yes. Why? Because here position of triple bond is 1. Here position of triple bond is 2. So position of triple bond is different. Therefore, these two are called position isomers, we can say. Next, we'll substitute n is equal to 5. N is equal to 5 in the sense C5H8 we can say. Now, first we will write 5 carbon atoms straight we will write. Okay, 5 carbon atoms we are written. Triple bond we will give at terminal. Next, 5 carbon atoms we are writing. Triple bond we are giving at between second and third carbon. Okay, next 4 carbon atoms we will write straight. Triple bond we will give at terminal. The another carbon we'll write it at down. Okay, these many possibilities we have given. Now we will give bonds, will give a triple bond between rest of the carbons, you give single bonds. So only one triple bond you give between remaining carbons, you give single bonds. Then let us give hydrogen atoms. Here this carbon is having one bond, therefore give three hydrogens. Next carbon two hydrogens. Next carbon two hydrogens. Next carbon no hydrogens. Next carbon one hydrogen. Okay, then for this first carbon three hydrogens, second carbon two hydrogens, next carbon no hydrogens, next carbon also no hydrogens, next carbon three hydrogens. For this first carbon three hydrogens, next carbon one hydrogen, down carbon three hydrogens, next carbon no hydrogens, triple bond, last carbon one hydrogen. Okay, now we will select a parent chain. We will select parent chain and we will say the name. Here parent chain contains 5 carbon atoms, therefore root word is spent. Here parent chain contains 5 carbon atoms, therefore root word is spent. Here parent chain contains how many carbon atoms? You see 4 carbon atoms, therefore root word is but. Now here carbon carbon triple bond, therefore ion is the primary suffix. Here ion is the primary suffix. Here also ion is the primary suffix. Okay, then we will say position of triple bond. We will say here position of triple bond is number 1. Okay, here position of triple bond, what we will say? Here position of triple bond is number 2, we can say. Here position of triple bond we will say, here position of triple bond is number 1, we can say. Here branch is present, branch name is what? In the sense methyl. This methyl present at which carbon? In the sense third carbon, therefore we can say this is 3 methyl but 1,9. Okay, so now we said the names for these compounds. Now you say which are chain isomers. Collect chain isomers. It is number 1, it is number 2, it is number 3. Now name the chain isomers. Which are chain isomers? You say number 1 and 2. Shall we say? No, because in 1 and 2 parent chain contains same number of carbon atoms, therefore no. Sir, shall we say 1 and 3? In 1 number of carbons in the parent chain is 5, in 3 number of carbons in the parent chain is 4, therefore 1 and 3 are chain isomers. Then shall we say 2 and 3? 2 and 3 shall chain isomers, shall we say? Yes. Okay, 2 and 3 chain isomers. Next we will say about position isomers. Which are position isomers? Do you say 1 and 2? 1 and 2, do you say position isomers? Yes, because in this compound position of triple bond is 1, in this compound position of triple bond is 2, therefore this compound and this compound are called position isomers, therefore 1 and 2 are position isomers. Then any more position isomers are there? Yes, 2 and 3, 2 and 3 position isomers. This compound and this compound position isomers. How? Because here triple bond present at second carbon, here triple bond position is 1. Here triple bond position and triple bond position here different. Triple bond position in these two compounds are different, therefore these two are position isomers, we can say. Then these three compounds, shall we say structural isomers? Yes, because structure is different for these three compounds, therefore these three compounds are called structural isomers, we can say. So in this way we can write alkynes. Okay, alkynes we can write like this. Sir, now I will take one compound. For that compound, what is the name? You have to say. Okay, so I will write one compound, CH3, CH3, CH2, CH single bond, CH double bond, CH2, 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 CH3. Okay, now for this compound, select the parent chain and say the number of carbons in the parent chain. Which is the parent chain? Do you say straight chain? Because that contains more number of carbons. Do you say straight chain is the parent chain? How to select parent chain? Is there any condition? Yes. In this compound, CC double bond is there. CC double bond we can treat as a functional group. So in this compound, CC double bond is the main group. Why we have to consider CC double bond as a main in this compound? Because CC double bond goes for chemical reaction very easily when compared to CC single bond. Therefore, CC double bond we have to consider mainly. Therefore, when you are selecting parent chain, see that parent chain must contain double bond, must contain CC double bond. So for alkenes, For alkenes, how to select parent chain means the parent chain must contain CC double bond. Okay, for alkenes, how to select parent chain in the sense the parent chain must contain CC double bond. Like this only we have to select. Therefore, what is the parent chain in this case in the sense the parent chain is this one. Okay, this is the parent chain. Now, if we consider like this, number of carbons less only when compared to straight chain, even then the parent chain is this one. Though number of carbons less in this manner, this is only called parent chain because parent chain must contain CC double bond. Okay, therefore, in this case, don't take straight chain as the parent chain. Straight chain is not parent chain here. In this chain contains one carbon less when compared to straight chain. Even then, it is the parent chain because this chain contains CC double bond. So, we selected parent chain, we selected. Okay. Now, for this parent chain contains how many carbons in the sense 2, 4, 6. Therefore, root word is X. Primary suffix is what? CC double bond is primary suffix. So primary suffix for CC double bond is what? In. What is that position? Double bond present between 1 and 2 carbons. Therefore, position of double bond is 1, we have to say. Then let us say the branch. What is the branch present here in the sense one branch is CH3. This CH3 is called methyl. Another branch is this. This branch name is called propyl. This branch name is called what in the sense? Propyl. Now, methyl is one prefix, propyl is one prefix. Two prefixes are there, which we have tried first, which we have tried next in the sense for which is coming alphabetically first, that prefix you write first. Okay, sir. Therefore, you write methyl first, then you write propyl. Okay, then we are writing propyl. Now we have to say the position of methyl and position of propyl. We have to say methyl position, what we will see, it is 3, it is 4, it is 5, it is 6. So methyl position is what in the sense fifth position, therefore 5 methyl. Propyl position is what in the sense 3, therefore 3 we can write. Propyl 3 we can write. Then we will write X1 in we can write. Next, in the propyl 3 carbons are there. Out of 3 carbons, which carbon is attached to the parent chain? This first carbon is attached to the parent chain. Therefore, this 1 dash we will write. In the propyl, first carbon is attached to the parent chain. Therefore, we are writing 1 dash. What is the necessity to give numbering like this? Why we have to say for branch also numbering? What is the necessity to say for branch also numbering? Because if you write the compound like this, now I will change the compound like this. Then now I am changing like this. Now you say, now see the branch position I have changed. Now see this branch, how this branch is there, you see. You see this branch. You compare both branches, you compare how it is there, you see. In this branch, all the carbons present in straight, but in this branch, second carbon is attached to parent chain. Therefore, only we have to give numbering to the branch also. So for branch also we have to give numbering. Okay. First we said for parent chain we have to give numbering. We said now we are saying we have to give numbering to even branch. Okay. So here we have given numbering like this. In this branch, how to give numbering means like this we have to give. We have to say that in the branch second carbon is attached to the parent chain. In this branch, we are saying that first carbon is attached to parent chain. Like this, we are saying. So in this branch, we are saying that 1 dash carbon is attached to parent chain. In this branch, we are saying that 2 dash carbon is attached to parent chain. Like this, we said. Okay. Now you say the name of this compound. Now, which one do you select as a parent chain here? In this compound, which one do you select as a parent chain? Parent chain must contain CC triple bond. Okay, therefore in this functional group is CC triple bond, therefore parent chain must contain CC triple bond, therefore this is the parent chain here. Okay, this parent chain contains how many carbons are there? See, as per that you say the root word, then primary suffix you say "-ine" because triple bond is there, you take this is as a branch and you take this is